In this chapter, we want to talk about how to construct the model in Euclidean geometry, and which can be used to make the models for non-Euclidean geometry too. And one of the kind of restriction that Euclid gave was only using straight edges and compass, and try to sketch out everything. So it's kind of very similar style like a postulate system. You start with a very restricted statement, but eventually you can building up the entire mathematical theorems. Okay? And how about construction? Yeah, not just to construct individuals independently, right? Rather, just restrict yourself with very limited tools. But eventually, through certain procedures, we can construct any model for that system. So Euclid suggests the straight edges and compass, and each one could do like make a line, okay, between any two, passing through any 2 points. And even there are some postulate he assuming like if there is a line segment, then we can extend this line segment to make the infinite line, right? So we're not questioning about that part. We just accept it. We can do that like that, right? And same thing happens for compass. Whenever we have 2 points, then we can use one of them as a center and the other point as a point on the circle. Then using compass, we can actually sketch the circle. Now, if someone asks you how or why, we cannot answer that. Right? It's just kind of, we accept that as a true kind of construction method. Okay? So we are not doubting about it, but after that, we want to construct all the other mathematical geometric model using those facts. Okay? So in this chapter, there are a couple of things you should be very careful about it because recently people accepting those, but traditionally it was not. Like it's a collapsing compass, okay? Which means when you have a circle at a certain point and you want to make kind of exact same size circle centered at another point like that, then someone might think, oh, then let me give me the compass and putting those way, and without kind of changing that angle of this compass, let me move this compass and place over there, right? So the meaning is you can keep that angle, right? Then just rotate it, then we got exact same compass. You know what? That is not true. Okay? That is not the Euclid meant, right? But recently, because of the, we always use this one in almost all the constructions. So people kind of accepting like a non-collapsing compass, which means what? To construct the congruent circle is easy, right? Exactly like this way, right? But please remember, it's not true. Okay? The traditional compass is collapsing compass, so we cannot do this way. And one of the construction in this chapter showing how to do that. Okay? So same thing is like this. You have a line, and there is a point. How can you construct parallel line? Yeah, just let me put my straight edges matching that line and push these straight edges up to here without changing the angle or whatever, right? And just I can sketch the parallel line there. It's not true, right? We cannot do that. Who can guarantee that we are not changing it? Same thing for the compass, right? How can you make sure while you are moving your compass on this place, if the angle is not changing? We cannot guarantee because it's collapsing, right? And even to make a same congruent line segment, right? So this is a given line segment, then starting from that one, on this line, sketch this congruent line segment. How? Yeah, let me put my straight edges over there and mark on my straight edges and place here. Then by the marker on the straight edges, I know the congruent line segment over there. That's not also true, right? You cannot mark on the straight edges. You cannot kind of fix that angle of the compass and not moving it, and you can sketch the congruent circle somewhere else. It's not also true. Okay? You know what I mean, right? So because of this, we require some more work for that, but It's okay. And there are very famous, these are the kind of construction postulate, right? I mentioned that. Draw a straight line from any given point to any point. Okay? So yeah, of course, right? You can do that. And produce a finite straight line, okay, or line segment continuously in a straight line, right? So we can just straight right there. Describe a circle with any center and radius. Okay, so now for the notation, because your task in this chapter is show the step-by-step construction, right? So for easier notation, using symbol is better than saying, oh, triangle ABC, right? So these are the notations. And let me warn you one thing. AB, that mathematical notation is for that geometric line segment AB, that's it. If you want to say the length of it or measurement of that, so or the size of this line segment, you have to say measurement of line segment AB, or because we use that on a lot, you just say AB without put any overline or anything. Then that is the actual real numbers, right? The size of it, 2.7. Okay? So big difference between these two notations. AB with overline, it's a geometric object, and just AB is a real number. Okay? Be careful about it. And if it's a line and line segment, AB is a line, but AB with arrows means it's a line, right? So this is a line segment and it's a line. If you have only one direction arrow, it's a ray, right? Going that direction like that. So angle ABC means that geometric object angle, but if you put M in front of it, that's the measurement, the size of angle AB, so like 25 degrees or something like that, right? For the center, we could use C and a point, which means it's the center of that, and radius of the circle. And that's enough to showing what circle we are talking about. So if the given circle looks like P and A, then whenever you want to mention that circle, it's got to be circle centered at P, right? And how about the radius? It should be like this, right? You have two ways to say it. AP, the line segment. That's good notation for radius, right? Geometrically. Or centered at P and just AP, which means we just give the length of it, like 2 centimeters or 3 inches. That is also good, right? So when you give the symbol or sign for circle, you could use either way. It's okay. And for perpendicular and parallel, okay, so these are the ones. And sometimes, because any geometric objects, the graphs and everything is a collection of points. So if two lines are intersect, like A, B, and C, D are intersect at point, if you write down that one, saying P is the intersection point between line AB and line CD, it's a long way to state. Okay? Instead, just using mathematical signs like that. So we just treat all these geometric objects are set of points, right? All the points like that. So intersection between these 2 points is just the 1 point, right? So we are not saying P equals AB intersect CD because that is a set notation. Then intersection of two sets is a set, right? So we have to say that. Okay? It's just between you and me. But if you want to write down as a whole sentence, it's okay with me. Now, I already made animation of this portion, so I'm not going to explain it. You can see that and you can find those from this PDF file, right? You can download that study book. Now, really, I have that case before. I mentioned that but the students didn't follow my suggestion. Okay, so didn't know that there is a nice way to watch those animations, right? So it's like this. When you click that the link of study book in your course Blackboard, it shows this PDF file within the web browser, right? Google Chrome or Microsoft Internet Explorer, whatever. Please, you have to download that PDF file into your computer and open it again using Adobe Acrobat Reader or something like that, okay? Then by doing that, whenever there is animation, you can see it. Okay? This animation is not working when you open this file within web browser, okay? So, and for this one, to see it again, click this one to the starting step and click those is a play button. So it means you don't need to do anything. It just shows each step-by-step procedures. If that is too fast, then you can using this minus, then it's actually make it slower animation. If it's too slow for you, then click this plus sign, then it make faster animation. But most likely, you might need just the step-by-step changes. So instead of playing the animation using this one, you can, by clicking one at a time, you can see each step, okay? Like that. Then when you're doing this, just look at each sentence here. Then it's kind of try to matching each other, right? So in the beginning, it says let AB be a given line segment, okay? And we want to make what? Perpendicular bisector of this line segment, okay? Then what is the next step? Draw a circle, C, right? And A means what? Center that A, and AB is the radius right now as a real number, okay? But doesn't matter which way. Next step, we do the same thing. But at this moment, the circle is centered at B and radius is BA. At this moment, AB, BA doesn't mean anything, okay? I mean, it's the same thing. The next step, mark the intersection points of these two circles. So notation is what? The intersection of the first circle and second circle is those 2 points, right? Then draw the line passing those 2 points, C and D. So this should be the result for that. Then this CD becomes the perpendicular bisector. Okay, so this one shows these two sides, AM, BMs are congruent, and these two lines are perpendicular each other like that, right? So there is no proof why it's really like that, right? But these are just construction steps, and your task is doing that. And you have all the hint through this animation, so please do. So first two, you have all these steps, right? To guide you. Okay? So in this case, these just arbitrary points over there, not the foot of this altitude from P, right? Except that point, you can choose just any points because you want to make two intersection points, right? Doing that. Then using these two, we can construct exactly the same as the previous method. Then that perpendicular line must pass in P. Okay? Then that is what we are looking for. Like this. So after that, you can just watch this video and state the step-by-step construction. Now, don't rely on this animation too much, right? So sometimes you might need more steps, right, to explain it. Sometimes you can skip it and write down all together at one sentence, right? It's up to you. Don't miss any steps, okay? And please treat me as your student, okay? And assuming I don't know anything about it, and you have to give me really detailed, kind explanation about the steps, okay? So you can just work on this way. And one big thing here is like this. This one shows how to construct that congruent circle, right? So not just use compass here and just move the compass here and just sketch it. It's not, it's a collapsing compass. So as you can see here, just to draw the line between those two centers. then using the previous one of the construction, we can get the perpendicular line passing this one, and that we found the intersection points with the circle. Then once again, for this line OB, we can construct perpendicular line passing B and perpendicular to OB, right? Then we can do the same construction at P. And there is an intersection point. Then now we have 2 points. Then use compass, we can sketch the circle. This is how really could sketch the congruent circle. Okay. The next one is, as recently is famous, for constructing this one, we need both Euclidean tools. The straight edges, like we need this line, right? And perpendicular line, and the circle, the compass, right? Because at the last moment we have to use compass to sketch the circle. But it is known, almost 100%, but not entirely proved, but all these Euclidean construction can be constructed by just using compass only. No needs for strategies, right? So it requires a lot more work. So in this case, that's the nice example. Okay, so like that. Then you see that just the circles, then intersection points, then the intersection points for that. Then using those 2 points, we have a circle, then find the intersection, then using those two, we can construct the congruent circles. So in this construction, we never use any straight edges, right? Or line segment or segment. Only circles, but you can construct, right? So it could be a nice kind of project, right? If you want later to find all this construction with only compass, right? Okay, so and starting from 9.2 is more complicated, but so in this case, whenever you need, for example, like a perpendicular line, you don't need to give all the detailed steps like we have done in this previous section, right? So in here, whenever you need a perpendicular bisector like that, you just say, we just draw a perpendicular bisector of AB. By what? By the one of the previous construction method, right? So you can skip those, all the detailed parts here, okay? So our assumption for this section is we know how to sketch those basic constructions, right? And we want to handle more complicated ones here. So it's not going to require that much lines here. Okay, so I think that's enough. And in this example, I didn't give you any animation, but from these activities, you should do that, right? You could do that. Listen carefully. This one is not a part of your assignment, okay? It just shows how to sketch that really complicated ones away, right? So just look at the animation is enough, okay? To see that. You can see how ugly these steps are, okay? Okay, so it's not showing all of them. Okay, so I think I need to change that setting, but from this one, actually, we can make the pentagon, right? Regular pentagon. But and over here, this one is not also part of your assignment, right? Just for practice, okay? For your reference, and this one shows how to construct it, but okay. 17 gun especially, it really takes a lot, and but please do, right? Okay. It's gonna be good exercise for that. And section 3 is about the non-constructible stuff, but if you have some small addition for your condition, then actually you can do that, right? So please just read this portion. And so there is no separate homework in this chapter, but just to do all these constructions, right? Up to example 9 to 10, right? So starting from page 11, you don't need to do at all, okay? but please do.